Hi everybody, hope you can hear me. As Becky mentions, I'm David Clipsham. I'm currently employed as the Digital Records Infrastructure Systems Manager here at the National Archives in the UK. I also have kind of lead responsibility for PRONOM research, hence why I've been asked to um, come in today. So I'm going to talk a little bit about PRONOM as a kind of high-level introduction, and also talk a little bit about file format identification, how that works. And then talk about contribution to PRONOM, which Jenny's going to go into in a bit more detail, I think. So to start off, let's talk about what PRONOM is. So fundamentally, it's a file format registry for digital preservation planning. So it's essentially a database of file format information that the National Archives publish and make available around the world. It was developed from 2001. Initially, I think it was Adrian Brown here at the National Archives who had the vision, and David Ryan as Archive Services Manager who kind of helped put it into place. But it was intended to meet the National Archives digital record preservation planning needs. So back at the time, we as an organisation decided that we needed to better understand the file formats that we would receive in order to best understand how to go about preserving them for long term. We looked around at the market at that time and found that there wasn't really anything out there that met our needs. So we commissioned to help us develop this tool. It's obviously grown since then. It currently contains 1,493 entries. So this is PUIDs or PRONOM unique identifiers. Each entry will represents a particular file format, and each entry may contain information around the file format extensions that are associated with the format, any MIME or media types that are associated with it, usually a description of the file format, links to any documentation that are available, and very importantly for us, file format identification signatures. So these signatures, they were developed originally for Droid, but they are used in other tools. So Siegfried, for example, which is embedded within Archivematica, that for example uses PRONOM, as does FIDO, and other tools that are also out there. File format research is always ongoing. It's part of the day-to-day job as the digital archivist here at the National Archives. The National Archives itself, our research is guided primarily by UK government need because that's the types of records that we are generally in contact with on a day-to-day basis. But also, obviously, we've got a responsibility as kind of lead of the sector, of the archive sector within the UK. So external contribution is always very welcome and very much encouraged. Just want to give a brief background to PRONOM. So the original version, as I mentioned, was developed in 2001. At that time, it was an internal version, and it did at that time talk not just about file formats, but also the software that's associated with it. Over time, we've kind of more kind of focused on the file format area. In 2004, PRONOM was opened up as an externally browsable resource for the first time. That was PRONOM 3. And then in 2005, we launched PRONOM 4, which introduced the idea of the PUIDs, the PRONOM unique identifiers, and Droid was also launched around that time. In the 16 or so years since PRONOM was originally developed, we've continued to kind of research, and we really kind of ramped up our research efforts around about towards the end of 2010. And we currently have a commitment as an institution to add at least 150 new entries each year, without losing any kind of the data quality that I think PRONOM is well known for. And the graph, as you can see, kind of illustrates the growth throughout that time. So to come on to file format identification, PRONOM enables this in a couple of different ways. So first of all, a way to try to determine what a file format might be is to look at the extension. So this is essentially the end of the file name. So like the .doc, the .exe, the .jpeg. These in Windows terms, certainly they kind of represent the applications that will be associated with the files. Now that is It's a way to determine what to do with a file, but it's not a hugely reliable way. You can manually change those things. It's a very Windows-centric view of the world. Unix systems and Mac systems, for example, historically haven't had the same those same kind of extensions associated with them. So PRONOM enables identification through file format signatures. The way a file format signature works is essentially through kind of scanning the internal bytecode of files, and it does a thing called binary pattern matching. It looks for patterns within the files that are registered within PRONOM, and then returns a hit where it matches up. So these patterns, they're created from elements of the internal structure of the files, and they may be quite simple. So a simple illustration is a Java class file, for example, where the first 4 bytes of Java class file are the bytes that represent that you did the value of cafe babe. That's a very simple way of doing it. But they can be very, very complex patterns, including variations, gaps, alternative values, and it's on the whole very much driven by what the file format specifications tell us where possible. There is a third view, which is the container signature mechanism, which I'm not going to go into in too much detail in this presentation. There is a blog post that was written by Ross Spencer about 1.5 years ago that goes into great detail about what Droid container signature are, what container sequences are, and how to construct them. Today I'm going to focus primarily on the binary signatures, and to do that I'm going to illustrate with an actual example that lives within PRONOM called the TZX format. So back in the 80s in home computing, particularly in the UK, but also across Europe and the States, there was this computer called the ZX Spectrum, very popular. So because it was very popular, there's been a large hobbyist community built up around it. And the TZX format was developed to essentially archive ZX Spectrum programs and enable their use through ZX Spectrum emulation applications. To load a program into the ZX Spectrum, it was typically the programs came on a cassette tape, and you would press play on the tape, and it would kind of screech down the line. It was basically transmitting bit pulse code to the computer, which would then interpret the bit pulse code as bytecode. It would reassemble it as the application. So the TZX format essentially captures this audio stream and kind of formats it in a way in which an emulator program is programmed to understand. So there are tens of thousands of these out there. The world of Spectrum is a very good digital archive of which has lots and lots of these things. It also now has a program entry. I've given it the entry of the PUID of FMT 1000. You can go and look at that, see what it's doing. So once we've got some samples of a particular format, we will then open it up within a hex editor and see if we can try to observe some commonalities between those samples that we've got. This screen is doing just that. So this is a hex editor open. We've got 2 files, one at the top, one at the bottom. These are 2 real examples of TZX programs. Now, it might not be immediately clear, but what I'd be looking for are the commonalities between these 2 formats. And if I go to the next slide, those are the commonalities that I immediately observe from those formats. So the next stage is to understand exactly what those commonalities might mean. And the specification, which for the TZX is a published open specification, you can go and find it. It is published on the World of Spectrum website, but also elsewhere. That tells you basically what that header is telling me. So the first 7 bytes of a TZX file, a valid TZX file, will have the value of ZX tape, ! Which is exactly what I see here. The next value is a byte, and it's the byte value of 1A. Again, that's what I'm seeing at byte position 07. And the following byte represents the major version number of TZX. In this case, it's the number 1. So for my investigation purposes, that's probably enough for me to be pretty certain that I can construct an identification signature based upon this specification with a good degree of accuracy. So that's a very high-level introduction as to kind of contributing to PRONOM and developing identification signatures. So why would we want to contribute to PRONOM outside of the National Archives? Well, for me, it improves the breadth, depth, and quality of PRONOM data, and also the coverage of format types that aren't typical to UK government. So as I mentioned, my day-to-day, generally, we don't get too much variety in terms of the types of formats that we receive, but we do have a responsibility kind of representing the archive sector, particularly in the UK, but also beyond, to include this data where we can. So we don't come into much contact with research data or geospatial data, for example. Others will, and it's of use for experts in those fields to kind of contribute to PRONOM to give us that information, so we can enhance it for the community. Research requests, they can be just quite simple. They can be just I've observed that format XYZ isn't in PRONOM. Could you please look at it? And we'll accept those requests. We'll add it to our backlog. Or they can be specific additions or corrections. You might notice that you've got a bunch of files that identify as a particular format, but the extension is wrong in some way. So that might be an addition to PRONOM or a correction to an existing entry. But you are also able to submit fully fledged entries. So if you've gone away and done the work and you want to submit a full entry into PRONOM that identified, we'll accept that too. We'll take that in. And there are a couple of ways to contribute to PRONOM. So the main one is PRONOM submission form. There's a link there. It's on the National Archives website, and it does usually return if you search for PRONOM submission form quite high up the ranking within search engines. We do have the Google group discussion form as well, and also a direct email, pronom@nationalarchives.gov.uk, where you can submit format samples to us. Today, over 50 institutional and individual contributors have contributed to PRONOM, including both Archivematica and the Borthwick Institute for Archives, who will both be talking, or representatives, Jenny and Justin will both be talking on their behalf today. And we also get contributions not just from the heritage section, not just from the archive sector, but also from educational establishments, and also private organisations now are contributing regularly to PRONOM. We do plan to make our research backlog available soon on GitHub. My target for that is towards the end of July. And anyone who contributes, we basically publish attribution on our release notes list, and the link at the bottom there. And just to illustrate the breadth of contributions so far, it is quite, there's a lot in Central Europe, well, a lot in Western and Central Europe and Northern Europe, scattering in Australasia and also North America. So if you're out there and you're watching and you'd like to contribute, particularly from South America, Africa, and Asia, please go ahead. We'd love to hear from you. So on that note, I'm going to hand over to Jenny to talk about how she went about contributing to PRONOM.
Hi. Oh, hello. I hope you can all hear me okay. My name's Jenny Mitcham. I'm the digital archivist at the University of York. I'm based within the Borthwick Institute for Archives. And my section of this presentation is really just to talk through my own personal experiences with PRONOM. I'll touch on why it's important to me and how I've engaged with it to try and make it better. So why is this important? I'm not going to read out this quote. I love this quote. I'm not going to read it out because I've tried practicing reading it out and it's a massive tongue twister. So I always get in a pickle. So I'll let you read that yourselves. The most important bit is the bit I've made bold in the middle, which is about the things that we now know that we don't know. The first time I saw this quote being used in a file formats context, I think was by Matthew Addis from Archivum, but I've stolen that from him now because I like it. So from a file formats point of view, what does that actually mean? So the known knowns are all the formats that PRONOM knows about and therefore the tools recognise. So we get a smiley face for that because everyone likes having known knowns. The known unknowns are all the formats that PRONOM doesn't know about, so the tools therefore don't recognise. And that's kind of a sort of a not a happy or a sad face, because there's something we can do about those, because if we know what we don't know, then we can act on it. We can add signatures to PRONOM. We can try and make that better. The real sad face is for the unknown unknowns, which basically, if we don't even bother running the tools over these files that we have in our care, we don't know what we don't know, so we're not really going to go anywhere with that, are we? And why is file format identification so important in digital preservation? Why does it matter what we know about the files? So one of the tools that I use quite a lot in my work is the levels of preservation from the National Digital Stewardship Alliance. I've just pasted a little bit of that table into this slide, and the line that I've pasted in relates specifically to file formats, obviously, because that's what we're talking about. So you'll see at level 2, which is called Know Your Data, you should have an inventory of file formats in use within your ARC repository. And you'll notice that if you look on beyond that at level 3 and level 4, which is what you're meant to do with these levels, you kind of start at the bottom and you work your way up. You'll see that the things that you have to do in level 3 and level 4 actually kind of rely on that knowing what you've got at level 2. So it's really hard to move up the levels unless you know what you've got. You can't monitor file format obsolescence issues if you don't know what you've got. You certainly can't start performing format migrations or emulation or similar activities that you might need to do to preserve the files. So this is why I get quite a bee in my bonnet about file formats. So I just wanted to mention a project that I've been working on over the last couple of years. It actually finished October last year. This project was really the reason why I started getting ever so slightly obsessed with file format identification. So this project was called Filling the Digital Preservation Gap. It was a project that we carried out with funding from GISC as part of their Research Data Spring initiative, and we carried out in association with the University of Hull. The aim of the project is stated here, which was to investigate Archivematica and explore how it might be used to provide digital preservation functionality for research data, basically. As part of this, obviously, we were working with Archivematica, so we did collaborate with Artifactual Systems in this project. We also actually collaborated with the National Archives, particularly in the later phase of the project, when I started to get this file format obsession. So as I said, the main aim of the project was checking out Archivematica, thinking how it could preserve our research data. But as part of the initial investigative work, I wanted to kind of understand our research data a little bit more in order to think about what Archivematica would actually do with those files. So if you pull the files into a preservation system, what happens then? One of the tools that Archivematica runs is a file identification tool, and I wanted to know if our research data could even be identified. So I ran Droid over a sample of research data that had been deposited with us at the University of York, and was quite horrified to discover that only 37% of those files were given an identification by Droid. I thought that was pretty low because with other sort of tasks of this nature that I'd carried out previously, we'd been looking at more like 90% or above for other data sets that I'd tried to run Droid over. So this was particularly low. Also worth unpicking on in this is the fact that of the files that were identified by Droid, a large majority of those were identified just by file extension. So David's already talked through the different types of identification, and the file extension identification is probably the least accurate of any of them, because it's just literally looking at the file extension and thinking, well, it's probably this. So this didn't seem like a particularly good result. If we're going to be preserving and managing research data for the longer term, we do need to do better than this. So as part of the project, we started to think about how we could make this better. There's clearly lots of file formats that PRONOM doesn't know about. We wanted to change this. So in phase 3, we actually sponsored a small piece of signature development work to be carried out at the National Archives by David and the team over there. But we realised that wasn't kind of a sort of solid, sustainable solution, because just getting David to create a few file format signatures doesn't really solve the problem. It just sort of scratches the surface. So we wanted to think about other ways that we could get more signatures into PRONOM, and we decided it'd be great to try and do it ourselves. And then if that worked, to try and kind of promote that work within the community and encourage more and more people to start doing it. So then David's graphs would kind of get a bit of a spike, and that would be really great. So this is just a quote from a blog post I wrote about this, saying, given the extent of the file format identification challenge for research data, wouldn't it be great if the community could engage more directly? Also, shouldn't file signature development be something every digital archivist should have a good understanding of? So here we go, and this is the blog post that I just mentioned. So in this, which I called my first file format signature, I talked through my methodology for how I created a file format signature, talked about some of the challenges, how it all worked, which tools and resources I used to do it. So I've got the link there if you want to follow up on that and read the whole thing. I'm going to skim over it in the next few slides, but the full details there. I should mention I was very excited that this blog post was translated into German as well. So if you speak German and you'd rather read a German version, then there's a link at the bottom for you there. I haven't read it myself. So it worked. These are just a couple of screenshots of the signature creation in action, if you like. So there's a little utility that the National Archives provide. Once you've discovered your sequence of magic numbers that David's already explained, and you've got the other relevant details about the file format, you can paste it into this little development utility. And when you click the button saying Save Signature File, what it does is it actually creates that XML file for you, and that's the file format signature, which is going to go into PRONOM and be used by Droid, etc. So yes, we had success. So I'm going to use the little tool here because I've been wanting to do this for ages. There you go. So this is the file format signature that I created. It's an omnic spectral data file. It's a file that chemists use at the University of York. It's quite specialist and specific, and to be fair, I don't really understand much about it, but it's nice, as David said, that you get that attribution on the Droid signature release, that you can kind of see, oh yes, I did that. So that's nice. And then there's a screenshot also of that particular signature file within the PRONOM interface as well. So just to talk through some of the challenges of this process, and then we'll move on to what you can do. The first thing for me was that I didn't start off with the right thing. So I had a bit of a false start at first with WordStar4. So WordStar4 files, they're not a research data format, but they're a format that I'd been working with in another context that I knew Droid Identify. I had lots of samples, so I wanted to kind of get stuck into that because that was another priority of mine. And it appears this wasn't a very good place to start. I couldn't find that kind of magic pattern numbers that David described and demonstrated. And I thought at first, oh no, this is too hard. I can't do this. I'm obviously no good at this. I'm not cut out for it. But I did then talk to David. I sent him an email and sort of sent him some samples and said, look, I'm struggling with this one. And he said, yeah, that's difficult. That is a tricky one. So it turned out it wasn't just me. It was that some files are genuinely quite awkward to create signatures for, and that's one of them. So then I thought I'd find unidentified binary format in our research data sample. And that was challenging again because actually an awful lot of the unidentified files in that sample of research data I'd run Droid over were ASCII. They were all ASCII formats. So a lot of them were things like DAT files and just sort of spitting out rows of ASCII data rather than being a binary format. Now you can create Droid signature files or PRONOM signatures for ASCII formats, but again, it's a bit more complicated than the binary formats. You have to get stuck into complex regular expressions and things, and I didn't really want to go there at this point. I'm not saying I never will, but for the first signature, I wanted to do a binary format. It's a better place to start. But finding an unidentified binary format that I had enough samples of to make it worthwhile was a challenge. So I had to rummage through the data quite a lot. So the file format that I finally selected, there was a challenge in that I didn't understand it at all. So this was a format that academics in the chemistry department use. I knew nothing about it. And that's not a very good place to start, because as part of the process of creating the signature, you have to give the file format a name, you have to provide a short description, and kind of getting those little things right when you don't understand the format or really what it's for is a little bit of a challenge, but we got there. Another challenge was finding the specification for the SPA format that I was working with. So there didn't seem to be any published specification that I could find online. I didn't go as far as actually asking the kind of the makers of the software. I could have gone down that route, I suppose. Maybe I should have done. And then the last challenge, I guess, was that the documentation that I was working with from the TNA was really, really great. And it was really detailed, up to the point where you find that sort of matching pattern, that set of magic numbers. So it kind of takes you through the process and explains everything, and then it gets you to the point where you find your magic numbers. And then it kind of, there was a bit of a hole because it didn't really tell you so much what to do next, or not in detail, and not in a way that I understood. So I had to go back and ask lots of questions and hassle David. But hopefully now I've published the blog, I've kind of included all that information about where I went from there. So that might help others in this situation. This is pretty much my last slide. I just wanted to end by saying, do try this at home. This is something that I think it's a really good thing to do, because if we all help, or if we all get stuck in, we can make PRONOM better. And because file identification is so key to digital preservation, to knowing what you've got then helps you move forward with preservation. But also kind of other reasons why it's good to do this is because I genuinely think it's really useful for us digital archivists to get hands-on and practical with our data. The actual process of creating a file format signature actually makes you understand some of the fundamentals of files and formats that it's really easy to gloss over. So I found that incredibly useful. I think before I did this myself, I genuinely did think that this sort of stuff like file identification happened by magic, because people talk about magic numbers, and I thought, yeah, it must be some kind of magic. By actually getting stuck in and trying it yourself, you think, oh no, it's not magic at all, it's quite logical. And that's a nice thing to know. So I thought it was actually quite good fun. It was a little bit geeky. I enjoyed practical and hands-on, and I'm not a hugely technical person, so I figured that if I can do it, then all of you listening can do it too. So I encourage you all to give it a go, and then we can make PRONOM better for everyone. So just a couple of links to finish off my section. There's some more information about that project I mentioned on our website, and from there's links through to our 3 reports that we created as a result of this project. So there's a link specifically on this slide to the phase 3 report, because that's the report that goes into most detail about the PRONOM work and sort of recommendations for taking that forward. There's also a link to my blog there, because I like to blog about this kind of stuff. So at that point, I'm going to hand over to Justin Simpson.
Hello, everyone. Hopefully you can all hear me. So my name is Justin Simpson. I work at Artifactual in Canada on the Archematica project. And something that is probably complementary to the process Jen just described, where you can, if you're working on describing, trying to develop a signature for a new format, there's a method that you can use FIDO to help you identify files, maybe while you're developing the signature or before they get into a new PRONOM release. So FIDO is a open source software application. It is maintained by the Open Preservation Foundation. The acronym means File Identification of Digital Objects. It's one of the tools, as David mentioned, that is based on doing file identification using PRONOM identifiers, PRONOM like PUIDs. FIDO is integrated into Archematica. One of the reasons that it was one of the early tools to adopt in Archematica is because it's written in Python, and it's pretty lightweight, and it's designed sort of based around the idea of being command line usage. So it's fairly easy to integrate it into digital preservation workflows. but in Archimedica, Siegfried is another tool that's available, and Droid is a third tool that's available, and there are potentially other tools that also can use pronoun identifiers, but I'm going to show you one particular way to use FIDO here. So a little bit more detail about FIDO first. So as we mentioned, there's multiple ways to do signatures, to identify files in FIDO. In FIDO's code, they refer to them as match types. The preference is to try to match based on a signature or based on the container. So for example, if it's a zip file or an OLE type format like a docx format, FIDO will fall back on using extensions as defined in the PRONOM registry if it has to, and then obviously fail is not a good match. It is possible for FIDO to return more than one result for a given file. So it's not always true. Any given file could match more than one signature, or an extension could be used in more than one format. I'll give an example of that. This comes out of, I just put a link here to the usage guide for FIDO from the OPF wiki. So FIDO uses PRONOM. The current version of FIDO includes the PRONOM signatures from version 88. At Artifactual here, we're actually working to help release a new version of FIDO that will include PRONOM 90 signatures, so it should come out in the next couple of weeks. What FIDO does inside is it uses the Droid signature files, but it actually converts them to an internal format. Partly this is because FIDO is based really on doing regular expression matching, and so it kind of converts the format that you see in a Droid file to its own format. There's a command argument that you can add when you run FIDO from the command line that allows you to add your own format files, so your own format definitions. So instead of only using the PRONOM registry, you can also add on additional files. You can define your own format. I'll show this example now. So here's an example of a very simple format. This is cut out. This is made as small as possible to make it fit on one slide. This XML file defines a format you'll see in the PUID section. It's a custom identifier, not really a PRONOM identifier, because this is my own personal extension. I've chosen a format with the extension MRC. I based this on looking at Jen's blog and seeing some of the files that she had sample files of that are not in the PRONOM registry, so I wanted to see if we could find a way to work with this. I don't know anything about this particular format other than having seen some, like basically Googled for it. So I do know, all I know to start is that there is an extension MRC, and so this particular XML file is not defining magic numbers or any kind of real signature. It just has an extension. So this is about as simple as you can get. So if I was to run that like this, you can see running the FIDO command and adding in the load formats argument, and I give it the name of my format extension file that I defined, and then I say the name of the file that I want to scan. And then the output from FIDO will tell you the version of FIDO that ran, and you can see in that line here, I think you can, I'm not sure if you can all see, okay, so it says formats version 88, and the container signature and format extensions. Those are the built-in signature files that FIDO ships with. And then you can see the match it came up with. It identified this format that I had defined in my own XML file, and it tells you that this was identified by extension. So we know this is not a great match, but it's now, at least we have some match and we have a name. And in Archimedica, we've done this in the past with examples of files. So for Archimedica users where they had files they wanted to preserve, they wanted to create records, premise events to show that they did identify these files. So we had some examples a couple of years ago that were disk image formats. And those formats were not at the time in PRONOM 84, they weren't listed. They're now, as of PRONOM 88 and 89, those have all been added. But we defined custom extensions to FIDO in this way, and we're able to have Archromatica then identify the files using a non-standard PRONOM ID. But it allows the rest of Archromatic's preservation activities to proceed, because the other activities like characterizing a file or extracting a container format or running like a normalization or any of those kind of activities would require, first of all, knowing the format. So as Jen pointed out, the NDSA levels, you can't get to level 3 until you're at level 2. So the main, one of the main pros of this is that rather than having to identify some files with one tool and other files with another tool, using this extension allows you to kind of add formats that FIDO is able to give some output about without having to run different tools. One of the main cons to this approach is that you have identified with a non-custom, with a non-standard identifier. So in this example, I've used this MRC files. It is important to point out that you can also have, if FIDO can give duplicates. So in looking into this, I realized that MRC files define this electron microscopy file format done by the Medical Research Council in the UK. And there's a specification for this, and this could maybe not easily, but it could be turned into a proper PRONOM signature. But MRC as an extension has also been used in a completely other context with an open source application called MIRC. That's a chat program, IRC, Internet Relay Chat program, and you can write scripts for that program, and they sometimes get saved with a .mrc extension. So here I've taken my initial format extension files and I've added another section. I've defined Justin FMT2, this new format, and you can see that it has 2 possible extensions. This is based on the Wikipedia page where I saw the MRC scripting language defined. If we then try running this on the first file again, this time I'm passing in a different, my second version of my format extension file. You see that FIDO has returned matches on two different possible results. So this is not great. It's possibly better than just coming back with unknown, but obviously duplicates are problematic. One potential way to deal with this is to start trying to identify an actual signature, not just identifying by extension. Here I've got an example of an MRC script, a very simple one-line script with some comments. There's nothing about this particular format, the way that this is not the Medical Research Council version, this is the IRC version, but this particular format does not have really anything. It's just a plain text, ASCII text format. It would be very difficult to define sort of a real signature for this because there's no characters that have to be in every file. I could easily make a script like this that doesn't have these first 3 lines with the comments having a semicolon at the beginning of the line. However, for the purposes of illustration here, I wanted to show that I can take the format where I defined this MRC scripting language, which just had extensions, and I can add in this signature section where I define a pattern. And I give it the position beginning of file, and I create a regex, which is just a single character, the semicolon. So basically, I'm telling FIDO here that if it can find at the beginning of a file a single semicolon, that would be considered a match. So if I run this now on my sample file, I now only get one match, and it's based on the signature. I wouldn't necessarily trust this signature because there are other files that could start with that same single character. But to illustrate the point, if you had a different regular expression that more accurately mapped, uniquely identified the file, you could easily use the same format to add it in. So that's the end of my section. This tool, this ability to use this kind of load formats argument with FIDO, I would suggest this is something you could use to help you as you're doing research with formats, to be able to easily add in, like, to experiment with matching to see if you have your regular expressions set correctly. If you're trying to identify text-based formats, for example, this would be particularly useful. To try to develop signatures for binary formats, as Jen described, you're probably better off using the example, like actually trying to create a proper PRONOM signature. And even here, I would consider this an initial step. At Artifactual, we've done this process in order to help understand some of the files that we've been trying to help our clients work with, and we have used these results to submit things to PRONOM. So it may be a way to help flatten the learning curve a bit, or to make it a little bit easier to get into understanding formats. So I will stop there and then hand it back over to Becky and see if anybody has any questions.
Okay, so Lee Hibbard is asking, should a signature be unique to only one place in the file, or can it repeat at different points in the file so long as it's unique to the file type? If I'm interpreting this question correctly, it's asking where the kind of patterns PRONOM is really looking for will be present. Now, this can vary quite greatly. Most of the time, you'll expect to see what we generally term as magic numbers in what we generally term as the header of the file. So somewhere near the top is where you're most likely to see those common byte sequences that we use for identification purposes. That's not always the case, though. There are some formats where the common sequences that you're seeing are at the very end of the file. Apple disk image format is, I think, one of those. There are some where the pattern appears quite deep into the file. So the ISO disk image format, that appears after, I think, it's 32,000 bytes. And in some cases, it is just a pattern that you're seeking throughout the file. So with MP3, for example, the MP3 audio file, it's basically you're looking for what they call a sync byte over and over throughout the entire file. So there are various ways in which these things can appear. So I hope that kind of answers that question.
I wouldn't necessarily recommend FIDO over Siegfried. I think that both tools could be used. There are definitely cases where Siegfried is able to return results faster. They're both based on PRONOM, but they have slightly different approaches to how they identify files. So the way that FIDO works is it's based on parsing regular expressions. The way Siegfried works is more a binary matching. It creates sort of an index in memory of possible matches, and it's much more of a sort of a B-tree index style search. So you should get the same results from both tools. In my experience, watching Archematica users use the two tools, I've seen that Siegfried tends to be faster. It also tends to be a little bit more conservative. So it will tell you that there wasn't a match. It'll say there was a match by extension, but we don't consider it a real match. Whereas FIDO will be more optimistic and say extension is good enough. So it's really just a matter of picking what you want. I've also seen some cases where we found minor bugs or problems in one tool or the other by being able to compare the results from both tools. So I think it's useful to have both tools. It's nice to have in an open source community diversity of approaches. It helps sort of to triangulate out, but I wouldn't recommend one over the other personally.
I just wanted to make a comment, Becky, that I forgot. I meant to say in my presentation and I forgot, which was really around workflows. This is something that we haven't, certainly at York, we haven't bottomed this out yet. We've got as far as thinking, okay, we need to identify these files, and we need to help work with PRONOM in order to do so. But we haven't thought about what happens when and how we actually incorporate that into our sort of generic workflow when we're ingesting files into the digital archive. And yeah, that's still a kind of an unknown for us, particularly for the research data use case, because for research data, the kind of prototype that we set up with Archivematica is designed to be pretty much fully automated. So we're just, the researchers are depositing files, Archivematica is grabbing them from a watch directory and ingesting them and making an AIP. So you don't have that human step where you have someone going in and saying, hang on, only about 3 of these files are identified. What about the rest? And then actually being able to take some action in that. So this is still the unknown, but it was interesting to see Justin's section about sort of interim measures within FIDO as well. It's another option for us.
Hopefully, Marley's question about the results between Droid and FIDO has been covered there as well. Yeah, I mean, fundamentally, there shouldn't be any particular difference. As Justin mentioned, sometimes the identification, sorry, the pronom signature file in FIDO is a little bit out of date from Droid. If you're running Droid up, if you set Droid to update every like the first time it runs, then you may find it's got a more recent identification of Droid and FIDO, but yeah, fundamentally they should more or less be the same. Coming on to Lee's question around how streamlined should a signature be. There's no hard and fast answer for this. It should ideally be driven by the file format specification where possible. That isn't always possible because the file format vendors don't always publish their official specifications, so there can be a bit of reverse engineering involved. In the specific instance you've given with lots of like kind of big FF sequences, FF is quite often used as a kind of padding block. So that might not always be present. So really, in an ideal world, you'd like to have lots of samples from lots of different sources representing the same file format, because you'll find different configurations might produce different results. What I'd very much encourage is a dialogue with either directly the PRONOM team via our email address, or if you want to make that public, then using the Google group is a good use, because there might be people who are kind of experts in the file format that you're looking to identify. Coming on to Vitali's question, can you make Droid look in a particular, or FIDO look in a particular place within a file? So say 32,000 bytes. Yes, so there is a mechanism. So PRONOM has an offset, has an idea of an offset. So you can set a file format signature pattern to start at, for example, in the instance that you've given, to begin at 32,000 bytes into the file. That in itself shouldn't take very long, but there are certain signatures whereby we're looking for patterns that could exist basically anywhere in the file, and that, depending on how big the file is, can cause identification results to slow down. I'm particularly thinking of broadcast wave audio files. Those instances we're looking for specific sequences that could turn up anywhere. Also, QuickTime movie files, MP4s, they're also looking for a particular sequence that can appear anywhere. So those files can take a long time, but it generally depends on how big the file is. So I hope that answers those two also.
I can add an extra quick comment on that last question. There's a parameter in FIDO that lets you set the buffer size. So by default, FIDO just looks at a certain, I think it's the first couple hundred kilobytes of a file. When we run it in Archematica, we set that to be the first megabyte of each file. And that's it's still using the PRONOM signatures and looking for the offsets that are specified in the PRONOM signature, but the buffer size allows you to limit how much of each file that you're actually trying to parse. So there are definitely trade-offs with that. So the examples David gave of like QuickTime movies, where often the identifying component is potentially quite far into the file or at the very end, that can be problematic, but you do have some control. It's worth looking at the documentation for FIDO and playing around with that. And I believe also Siegfried has ways. Siegfried comes with a tool called Roy, which you can use to customize to a large degree how Siegfried is going to work. So in both those tools, you can it's worth looking at the documentation and playing around with them.
And similarly, Droid in the tools properties file or tool properties menu, there is an option to change the amount of the max bytes to scan, I think it's called. The actual out of the box Droid configuration is set to only scan the first and last 64,000 bytes of the file. Generally recommend setting that to a minus value, which ensures that the entirety of the file scans. But again, that does add the cost of performance. It can take a longer time to get an accurate, to get a positive identification result. So yeah.
Okay then, I think that if there aren't any more questions, we'll leave it there for today. I will email around some of the links from the presentation to all participants, and yep, I hope you join us again on another webinar. Thanks very much, everyone. Bye bye.